Hi guys, we are on lesson 4 of unit 3, fractions on a number line. Today we're going to be able to use number lines to represent, compare, and rename fractions, use equivalent fractions as a strategy to add and subtract fractions, and also apply and extend previous understandings of multiplication and division. As a warm-up here, we've got 3 different situations. So on a slate or on a piece of paper, I want you to write a fraction that models each situation. The first one here, let's take a look at it. Let me change to this one. 3 containers of paint shared by 10 people. 3 containers of paint shared by 10 people. Hopefully you got 3 shared by 10 people. Next one, 3 cartoons. I bet that's supposed to be cartons. 3 cartons of orange juice shared by 9 people. 3 shared by 9. Hopefully you got 3 shared by 9. And fun fact, we can reduce this one. 3 divided by 3 is 1. 9 divided by 3 is 3. So you could make an equivalent fraction of 1/3 in its most simplified reduced form. And the third one, 6 apples shared by 8 people. 6 shared by 8. Hopefully you got 6 shared by 8. And again, just like the other one, we can reduce. I see they're both multiples of 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So 3/4 would be our reduced fraction. But 3/9, 6/8, and 3/10, those are the numbers that we're really looking for. If you got these, bonus to you. As usual, we have vocab terms. First one is interval. So an interval is the set of all numbers between two numbers, A and B. So we have, here is a unit interval. So here's 0 to 1, and you have stuff that's inside of this. You could also have an interval between the whole numbers, 4 to 8. If we look at 0 to 1, those would be part of a whole, or what we've been practicing, whole number or fractions, sorry. You'll notice that should be changed. The application, we're not interpreting remainders right now. We are fractions on a number line. I'm not sure why these 2 slides didn't fix. My apologies. And we've talked about mixed number before. Remember, a mixed number is a whole number and a fraction combined. Go ahead and turn to page 80 in your journal. And you should see a number line. So on that number line, I want you to look at this and listen to this story problem and try to mark these places on the number line the best as possible. Ida, Nathan, and Janice were running at track practice. After 12 minutes, Ida had run 1.5 miles. Nathan had run 3.5 miles, and Janice had run 3/4 of a mile. Mark the number line in problem 1 on journal page 80 to show where each runner was after 12 minutes. Be as precise as you can. Label each mark with the runner's name. So I want you to pause right now and pause it on this screen so you can come back and read this, because this story problem is not in the journal. And then come back and we'll talk about, I'll draw a number line for us to look at and kind of go over where those spots should be. So here I've created a number line, 0 through 2. And you can see I put some different X's here to represent. I labeled this blue one. It's halfway between 1 and 2. and I labeled it with an I for Ida. I also labeled a purple X with an N for Nathan, and then I labeled a G for Janice for her 3/4. I want you to notice that I put the I and the N at the exact same spot. I want you to think about that. Why would I put 1.5 and 3/2 in the same spot on a number line? So we'll come back to that in a minute. Just some important features of a number line to keep in mind. Number lines go on forever in both directions. We show this by drawing arrows at each end. So you'll see I put an arrow here and an arrow on this side. Tick marks on number lines are evenly spaced. We label tick marks by counting up by a given jump or interval, such as 1, 10, half, or fourth, so on. So on my number line, you see that I had a 0, then a 1, then a 2. So I use the intervals of 1. We decide how to label number lines, including the tick marks on number lines, based on the numbers in a problem. So by looking at the problem that we previously had, I saw that it would only go up to 1.5, so I went up to 2 on my number line. Labeled tick marks help us place specific values on the line. Tick marks for whole numbers are sometimes longer and bolder than tick marks of values between whole numbers. We use points or dots to represent specific values on a number line. This time I used an X. We could have used a dot. So think back to the math message. How can we show 3/4 as precise location on a number line? Let's see what they say. So the space between 0 and 1 is one whole, and just as one red fraction circle is one whole. So that's something to think about. When you're looking at this number line, we want to think, all right, if I'm talking about 3/4, I want to split this into 4 parts. So here I have 2 parts. I went down the middle, and then I could divide this into 2 even smaller parts. You'll notice that I have 1, 2, 3, 4. I have 4 parts to it. Where would 3/4 be? Right here, because I can see that I go 1, 2, 3. And you'll look over here on this number line. I did try my very best to get that the best place possible. You can see that 1, 2, 3/4 is where I put G. So on this slide, you can see that it says the point at 3/4 is 3/4 of a unit from 0. So if we go to 0, we move 3/4 that way. That is where the point is. We want to make sure that 1.5 miles and 3/2 miles were labeled as precise locations on a number line as well. So taking a look at the information they provide us, we want to think about whole numbers first. Since 1.5 is more than one whole, we want to jump up to that tick mark for 1. Think about the place between 1 and 2, and that's what I did there. I thought about, all right, I have 1 here, I have 2 here, I've got 1.5 miles as this number, so right here would be a half. One whole and make a tick mark halfway between 1 and 2 to show halves. Label the mark 1.5. Place a dot on that 1.5 mark. Count 3 half-unit intervals from 0 to 1.5. Take a look at this. So we've got 0, 1, and 2. But if I do my half marks, here's a half, here's a half. I can go 1, 2, 3 halves. That's right here, 3 halves. So that shows me that 1.5 and 3 halves is the same. Now, I think I showed this to you in a previous lesson, but we can check this. We can see, are these two things actually equal? Remember, I can take the 2 times the 1, and I get a 2. And then I can add that with this one, and we get a 3. 3 halves is the same or is equal to 1.5. So were your places the same as mine? And if they were we correct? So I want you to think about the strategies that we just reviewed with and revise your labels in your journal if you didn't have them in the same area or correct area. So when we think about fractions that are greater than 1, such as the example of 3 halves, the numerator is greater than the denominator. That is indicating or telling us that it represents more than one whole. In the math message problem that we just did, the number line representation for Janice, Ida, and Nathan, which one would represent this? Who went the farthest into 12 minutes? How can you confirm this with your fraction circles? So you were just using a number line to compare the fractions or determine which fractions were greater, less than, or equal to each other. We can use fraction circles. We can use number lines to help us with fractions as well. When you're thinking about representing your fractions other than halves and fourths, how would you do that? What if other students ran different distances on tracks? For example, what if somebody went the distance such as 1/3 of a mile? What would you do? So I'm thinking about that, and I'm going to simply draw a number line between 0 and 1. I forgot to put my little arrows. 0 and 1. And if I'm thinking about 1/3, I know this right here is 1/2. But that's not what I want. I want to represent 1/3. So I'm going to show you a different color here. And I'm going to think about this whole. I'm going to go from here to here. And I'm going to split that into 3 parts. So I'd probably put a marking right here and a marking right here. Because that'll show 1, 2, 3. 3 equal parts. So if I want to show 1/3, I would know that that would be right here. 1/3. So you can answer this. Is 1/3 greater than or less than a half? Well, look at your number line right there. It's less than a half. If you have closed your journal, please open it back up to page 80. We're going to be working on moving forward with representing our fractions on the number line. So I want you to partition and label the number lines in problems 2A and 2B on page 80 to help solve this problem right here. Gary ran 1 2/3 miles, and Lena ran 7/6 miles. Who ran farther? We want to remind ourselves when we're looking at these. This one has a whole number with a fraction, so it's called a mixed number. This one has a numerator that's greater than the denominator, so it's actually considered an improper fraction. But what we also know and remember from the previous slides, the numerator is greater than the denominator, so we know this is at least 1 mile. They both ran more than 1 mile. Now we need to figure out, is 2/3 fraction greater or the fraction that lies with this one? When you're thinking through this, you can ask yourself, 7/6, what would be it as a mixed number? I like to think this through and think, all right, 6/6 equals 1 whole. How many 6 do I have left to get to 7? I have 1/6 left. So if I do plus 1/6, that's going to get me my 7/6. So 1 1/6 connects with Lena. We want to decide 1 2/3 or 1 1/6. What you could do is put this on your number line, cutting up the parts of the number line to represent sixths and thirds. Another thing you can do if you're ready, it's okay if you're not, but you can look at the fraction of 2/3 and you can make an equivalent fraction to something over 6. I want to ask myself, how can I get from 3 to 6? Well, I multiply by 2. If I do it to the bottom, I'm going to do it to the top, and I can say 4/6. So I'm now comparing 1 4/6, comparing that to 1 1/6. This is easier to compare. I now can say 1 and 4/6 is larger than 1 and 1/6. So who ran farther? Gary. Gary ran farther. Here is an example with the number lines and the fraction circles to represent the math that we just did. Here we can see that um, Gary ran 1 and 2/3 number line. And this number line down here, we split it up actually into sixths. So you can see 6/6 was right here, and 12/6 is the same as 2 because 12 divided by 6 equals 2. And you can see 7/6 is right here. When we are using a number line like this, it's nice to, you can use a straight edge and draw a line like this to see where each person's amount went. And you can see that this one was further to the right. I want you to note, though, that it's not always necessary to place your fractions in a precise location in order to compare your values. You can use fraction pieces to help place the fractions on a number line. As long as you have them in an area that's close and logical, you should be able to figure out where they are falling roughly on a number line. So back to page 80 is now time for you to work through some problems on your own. We see problems 3 and 4. Number 3 says which number is greater. So you've got A, B, C, and D, where you can compare your fractions and mixed numbers. Number 4, Rachel and Dan are growing plants in a science class. Rachel reports that her plant is 1 1/4 inches tall. Dan says his plant is 5/2 inches tall. Whose plant is taller? And how do you know? For problems 5 through 10, I want you to rename each fraction as a mixed number or each mixed number as a fraction greater than 1. So you're creating equivalent names. You may use your fraction number lines poster if you can access that on the Everyday Math website, looking in the SRB. You can use the fraction circle pieces on the Everyday Math site, or you can use division, and you can also use the little trick that I showed you. And finally, for number 11, rename 34/8 as a mixed number and explain your reasoning. Explain how you did that. So pause your video now and come back and let's check our work. Taking a look at problems 3, 4, 5, 6, 7, 8, 9, and 10, or 3 through 10. Number 3, 3A, 9/10 is larger. B, 1 5/6 is larger. C, 2 1/4 is larger. And D, 9/6 is larger. On number 4, Dan's plant is taller. How do we know this? 5/2 is the same as 2 1/2, and 2 1/2 is greater than 1 1/4. 5 is equal to 1 2/3. 6 is equal to 16/9. 7 is equal to 1 3/8. 8 is equal to 11/6. 9 is equal to 3 1/5. And 10 is equal to 7/3. And finally, number 11, renaming 34/8 as a mixed number is equal to 4 2/8. Explaining a reasoning could look something like 34/8 is equal to 34 divided by 8, which is the same as 4 remainder 2, but you can turn that remainder into a fraction, which is 4 2/8. That is the end of lesson 4. Again, we are working on fractions on a number line, using number lines to represent, compare, and rename fractions, and using equivalent fractions as a strategy to add and subtract our fractions. And also we're working towards applying and extending our previous knowledge of multiplication and division.